I'd like to express appreciation not only to Gerald, but to the organizers, the local organizers of the conference. They're behind the scenes, and over the last half century, I've organized many, many conferences, and I know the extent of work that there is. And the people who attend the conference, we don't realize how much work they had to do, and I'd just like to take this chance to express my appreciation for what they've done. Now, today I'm going to talk about changing the water properties with a variety of different kinds of things: lasers, magnets, certain kind of geometry, and as well as conscious intention. I got interested into this kind of material about 3 years ago when I got interested in subtle energy. And I realized that I wasn't happy reading whatever I was reading, and that the only way I would know about it was to start my own experiments. But to start experiments, one has to have a lay of the land. And so what I'm presenting now is something about the lay of the land and the kind of measurements that I was able to make. I'd like to acknowledge help from Jim Caffrey and Haralick, who were essential for some of the experiments. All right, so here's the purpose: to explore the extent of differences in instrument readings on different kinds of water, and to see if treating water with lasers with different wavelengths, magnets, different kinds of polarization, circumferentially, axially, and radially polarized, one particular copper geometric shape, and as well conscious intention. And we want to know from these experiments, is there anything more for us to explore, or have we just reached a dead end? So I'll let you be the judge. The instruments we use as a vector network analyzer, which is what I'll show first, an impedance analyzer, and a spectrometer. The vector network analyzer is a Tektronix TTR506A. It has a frequency range of 300 kilohertz to 6 gigahertz. Over here is a flat plate capacitor that we used as the probe. This is probably different than many of the kinds of experiments that are done with impedance analyzers, because what we wanted was actually the capacitive effect. If the water, by the treatment with the magnets, changes, then there are many things within the water that can change. Two things that I thought of that were measurable indirectly related to the water permeability and to the water permittivity. And both of those are a function of frequency. It's not just the constant that you see in the textbooks on the permittivity of water is whatever, 80 times the permittivity of air. They're a function of frequency, and you're going to see this. We had the experiments were done in a Faraday cage. It consisted of a copper pipe, 6 inches in diameter, which was lined on the inside with permalloy. Permalloy is actually better than mu metal. It has a permeability, relative permeability of 100,000. The mu metal depends upon the particular alloy that you use of mu metal, can go between 70,000 and can reach 100,000. All right, what does the vector network analyzer measure? It measures the complex value of the reflection coefficient. To understand this, you have to recognize that we're using high frequencies. In high frequencies, everything that's going on, in a sense, can be looked like transmission lines and impedances. So the coaxial cable and the wires that connect the VNA to the capacitor are essentially acting as some kind of a compound transmission line. The capacitor is not a capacitor only. It's both an inductor and a resistance. And both the capacitance and the inductance changes with frequency. And it's the complex impedance that we're trying to get at through the reflection coefficient. So the vector network analyzer sends a sinusoid with a phasor called V+. The capacitor end of the transmission line sends back a sinusoid phasor V-, and V- is the reflection coefficient times V+. And if V- is not equal to 0, the result is a standing wave on the transmission line. And the formula on the bottom is the formula that relates the impedance, the characteristic impedance of the transmission line, the complex impedance of the load to the complex reflection coefficient. So what are the measurements? We're going to make measurements of 3 kinds. The measurements are related. If you look at the complex coefficient and you look at it in terms of a function of frequency, you look at it in the polar form, you have a magnitude times e to the j theta, and that's the phase. Notice that the phase is a function of frequency, the magnitude is a function of frequency. You can look at it in the rectangular form as the real part and the imaginary part. And there's something that's called the group delay, which is minus the partial derivative of the phase angle with respect to frequency. So we're going to look at those. This is a frequency. We're going from approximately the 300 kilohertz through 1 gigahertz. And you can see the pattern of the reflect. What we're seeing is a scale on the y-axis, which is the linear magnitude, and the frequency is on the x-axis, and that you can see that it has different maxima and minima. And this is the pattern that we're going to see that is changing. So this is without water. Now let's take a look at the magnitude. We just put tap water in. What I want you to do is see the difference. The pattern has changed. That's the point. One of the waters that we're going to look at is a Boyce water. It's called the water smacker. It microstructures water by actually making longitudinal waves within a waveguide, which is on the inside the cylinder, for longitudinal waves. And the water is pulsed with very sharp pulses with 2 Tesla coils. Again, here is the linear magnitude of the Boyce water, something completely different than the pattern that we saw before. Just for comparison, here's the tap water. All right, now let's go to the experiments with the treatment. We have 3 different kinds of magnets. This magnet here is composed of 12 segments. It is circumferentially polarized. And just as the last speaker said, when the magnetic field is within the ring, if the ring were perfect, the magnetic field doesn't go out of the ring. So essentially, there's no magnetic field in the center or the whole of the ring. You see here a test tube of water. The test tube is about 8 inches tall, 1 inch in diameter, holds not quite 100 milliliters of water. And so you see the test tube having the water in it and being put into the center of that ring magnet. So if there's not a magnetic field, what is there? So what would one say is it's the vector potential field. That would be the classical answer, and we can stick with that, but I think it's that and plus something else, and we don't know all the something else until we change the Maxwell equations into the Clifford algebra and see what results beyond the vector potential. But anyway, what's in there is not a magnetic field. That's the point. This is water from an Idaho hot spring, and you can see a different pattern when this is put. This is before treatment. This is after treatment. Before treatment, after treatment. Here's the delay. Before treatment, after treatment. Look at that change. If you just look at phase, well, there's something there, but it's not as dramatic as in the other. This is the real part before treatment, the real part after treatment. Before treatment, after treatment. The nature of the harmonic distortion that you see on these, what you might say are sinusoids, is different. This is the imaginary part. Before treatment, after treatment. Before treatment, after treatment. Let's take a look at the axially polarized now. These are ring magnets which are axially polarized, so the top surface is like north, the bottom surface is south, and we've just stacked a whole number of them together. The magnet that we used in the previous one was neodymium N42s. These are ceramic ferrite C5s. This is before treatment, the Idaho Spring linear magnitude. This is after treatment. The phase, there was something there. You see it dropped. The delay, it's something close, but some things are showing up in the 400 megahertz to 800 megahertz area. This is the real part. This is the well, hold on. What did I do? This is the real, and this is after treatment. This is the imaginary before treatment. This is the imaginary after treatment. Finally, let's take a look at the radially polarized. Radially polarized means that the inside circumference, let's say, is north, and the outside circumference is south. So you have two possibilities for radially polarization. In this one, it's south on the inside. There's the linear magnitude. By the way, you need to watch the scale here. It's not the same as the previous ones, but they're all consistent for this run. That's what happens after treatment. Before treatment, after treatment. The delay, before treatment, after treatment. The phase, before treatment, after treatment. Not much change. The real, before treatment, after treatment. The imaginary, before treatment, after treatment. And finally, let's take a look at the radially polarized with north on the inside. And by the way, the treatment was lasted for about 20 to 30 minutes. Here, the frequency scale here goes up to 100 megahertz. And I'm showing you this because there's a change here. And we looked at the up to 100 megahertz, that's a tenth of what I was showing you before, with the other experiments, but there was not much change. The change was much dramatic when I looked through 1 gigahertz range. But in this case, this is dramatic. Here's before treatment, and here's after treatment. All right, here's linear magnitude. Before treatment, after treatment. Delay. Before treatment, after treatment. This is the full 1 gigahertz. The real. Before treatment, after treatment. The imaginary. Before treatment, after treatment. We looked at some waters that also do structures. This is the AquaCure water, in which they hydrolyze the water, generating Brown's gas, and they bubble the Brown's gas through a series of chambers, and the water that results at the end is a high pH water. And George Wiseman, who's the inventor, of course, tells us about all kinds of special properties the water has. So we looked at it. This is before treatment. Notice, by the way, this AquaCure water is completely different than tap water. It's completely different than the Idaho spring water. Circumferentially polarized. Here is the Boyce water, the ones I showed you before, linear magnitude, circumferentially polarized, before and after. And here's hot spring water, linear magnitude, circumferentially polarized. There's a difference. This is Acadia distilled water. This is the linear magnitude before treatment. This is after treatment with circumferentially polarized magnet. Quite a difference. So there were no variations due to the vector network analyzer coaxial cable positions. I can put my hand any place along that cable, and there was absolutely no change. There were some variations produced by the positioning of the wires to the dielectric probe, and we now see that those wires need to be very rigid to keep the geometry the same. The different magnetic polarizations did make a difference, and we need to understand why we observed the changes we observed. Now, in the impedance spectroscopy, we also use the same capacitor. Here I gave the two-plate capacitor had a nominal capacitance of about 0.14 nanofarads in the air. The impedance analyzer was an HP 4192. It generates a 300 millivolt signal, and the frequency is scanned from 1 kilohertz to 10 kilohertz. That scanning is actually done manually. And for each chosen frequency record, we record the impedance magnitude and the impedance phase. And in this series of run, we're doing experiments involving conscious intention. There's a picture of the magnitude, and you can see from the Nixie tubes, that's where I read the result, and the buttons allow me to put in what the frequencies I want. For this experiment, we used the Acadia distilled water. It's sold in 1-gallon containers. The water was kept in the same room as the experiment. The water was acclimated to the room for a week, and the room temperature was kept at 24 degrees centigrade. Holding conscious intention. This is a little tricky because you have to set conscious intention, and then you have to hold it, which means you release all holds on all efforts. You have to be effortless. If you will, you have to be a bit free and spontaneous in the moment, and some people describe this as even a bit of spiritual play. Use of effort or mental effort, that kind of force can produce the opposite effect in an experiment. And the example I'll give you that, which I think you can immediately relate to, suppose I tell you not to think of a pink elephant. Now, be serious about it. Not to think of a pink elephant. What's going to happen? So, for most people, they say, oh, I got to put effort into not thinking about a pink elephant, and then all that goes through their mind is a pink elephant. So, the way you have to handle people who do meditation know how to handle it because it's an effortless thing. So, you set your conscious intention, and then without any mental effort, go on to what the experiment is. This shows you just the particular points. There are two sets of points, one in red, one in green. One is before intention. The other is after 2 minutes of intention. And Jim Caffrey is the person who had the intention. There are the curves. That's on the magnitude. Here is conscious intention cycling. This is a method that was developed by Bill Bengstum. And Michael Hobson is the practitioner. Set the intent to facilitate handling, rapidly cycle in the mind happy images, and you cycle for 1 minute. So these are the points that we measured. There is the curve before and after on the magnitude. There's phase, and there is phase only part of the range from 10 to 1,000 kilohertz. There's another part of the phase. The last experiment was done by Jim Caffrey. The results of the points are shown here. And you can see that there is a difference in some portion of this curve on the magnitude, and there's a difference in the phase. And here's another version where we take a particular part of that phase. We actually had 4 experiments. The first experiment I didn't show you because it was the first time that we put the capacitor in the water. And evidently, in this process, there's a conditioning process for the electrode. And so if you look at the purple lower one, that was the magnitude curve that we got from the first time. You look at all the other 3 others, they're in a completely different place. This is the curve of impedance near that resonance point. You can see that all the curves are lying very close together. This is a curve of the phase. All of them are together, 3 of them, and the one that's purple is Caffrey's first experiment against the untreated water in experiments 2, 3, and 4. And you can see we have differences near the bottom of the curve for that. Here's another one, and you can see the purple is standing out. And here's a third one, and the purple again is standing out, but it's on the other side. So, the summary of these experiments was the change induced by Hobson's intention created a phase increase before the resonance point. Caffrey's intention created a phase increase before the resonance in trials 3 and 4, and created a phase decrease before the resonance in trial 1. And I have a suspicion that what's really going on is Jim Caffrey was trying too hard in the first experiment, and so actually got an opposite result. Finally, let's move on to the spectrometer. We used an ocean optics spectrometer, wavelength between 200 and 1100 nanometers. It's put together with the light source, and the light source is a 2-bulb arrangement. The light source had a frequency range, a wavelength range of 180 to 1100 nanometers, signal-to-noise ratio of 3 to 1, and so on. On this particular set of what I'm going to show you now is an average of 40 transmission spectrums with a box filter applied to each of them of 5, just to make some bit of smoothing. The cuvettes that we used were Brandtech Scientific Semi-Micro UV Transparent ones. It's a polycyclical olefin plastic. The band pass is from 230 nanometers to 900, although we saw that we got some transmission through even at 210. Manufacturer says they're grouped by manufacturing, mold, cavity number, to ensure the lowest variation in extinction coefficients. Nevertheless, we found that every time we used the cuvette, we had to calibrate. And furthermore, if we reuse the cuvette, listen to this, the water that we put into the cuvette imprints on the cuvette. And then we put new water in the cuvette that hasn't been treated. And then what do I see? I begin to see patterns that look like the water that I had just treated before. So you get cross-contamination this way, and I think it also goes with the quartz cuvettes. All right, here is the copper geometric shape. My wife calls this an orb. Go to the 8 vertices of the cube. From each of the 8 vertices are 3 copper tubes. The center one, differentiate between the front face and the back face. If you look at the blue vertices in the middle. You'll see there are 4 that look like they're in a diamond, 1 that is forward and 1 that is back. Those vertices are exactly the vertices of an octahedron. And if you look at the middle one from each of the vertices, you'll see the middle one of the front face goes to the bottom vertex or the back vertex of the octahedron, and those that are on the back vertex go to the forward vertex. Anyway, how this shape came up to be dreamed about, I don't know. I can't answer that question. But I do know that when this shape, there's a picture of it. It was made by my wife, and if you go to the website playdance.haralick.org, you can see a whole selection of copper things that she made. The copper tubes are 1 foot long. The cuvettes were treated in the center. So this is just a short video. Oh, you got to get this away from it. Yeah, play it again. Maybe this gives you a better idea of the shape. This gives you a feeling of it as it's rotating. All right, so we treat the cuvette 20 minutes in the inside of that geometric shape. The untreated is the one in purple below. The treated one is above. I'll show you 9 examples. There's the second one. There's a third one. There's a fourth one. There's a fifth one. There's a sixth one. Do you see the pattern? There's a 7th one. There's an 8th one. There's a 9th one. This is the kind of variation that we saw. And actually, it looks like these variations in part are determined by the orientation of that shape with respect to the Earth's north magnetic field. That orientation is important, and it turns out the geometry of how you place that cuvette in the center and how you hold it, how it is with respect to the rest of the geometry of the shape also plays a role. So we have some variations for those reasons. Now I'll go through the last set of experiments. We're going to use lasers for this, but there's one special laser that we're going to use as well. It's a 405 nanometer, 5 milliwatt laser that's been pulsed with a sequence of 2,200 beneficial cell optimizing pulse rates. Drinking water that's imprinted with this laser increases balance, provides pain relief, and speeds wound healing. And I can tell you something. I've seen the increase in balance demonstrated with a number of different people. And I was sitting at the dinner table with Leonard Knell, who was the inventor of this, an orthopedic surgeon. And at the dinner table, some people had ordered wine. Well, it was cheap hotel wine. It means it was expensive, but was really cheap wine, right? So they took a tape, and he asks them, how does it taste? And they, bitter. He says, can I shine my laser in it? He takes out his pocket from the laser, 5 seconds in the one, 5 seconds in the other. Now taste it. And they taste it, and they say, my goodness, this is a mature wine. So that's the reason why I decided to use it. The first set of experiments is going to be on Divinia water, manufactured by Stephen Settlemeyer, who says that this water is related to easy water. It's deuterium depleted, greater hydration, greater oxygenation. We measured a pH of 9.59 and an ORP of 252 millivolts positive. These are the graphs of the canal versus the original. You can see that there are some places where the purple is showing out. This is the 405 nanometer laser, standard laser pointer. It's different. 450 nanometers, you can see a change. 532, no change. 635, no change. 650 nanometer, there is a change. 808 nanometer, there is a change. And no, 808 nanometers, look, we're on one side of the spectrum, and what do we see a change? In a whole broad band on the other side of the spectrum. And here's an 850 nanometer. Change both on the low side and the high side. So that's the summary. Let me try just another water if I have like 3 minutes. This is the Wat-Ah water, and there's a patent on it. The water from our unopened bottle measured pH of 6.52, and the ORP measured 426 millivolts. Treated with the Nell laser, you can clearly see there's a bigger difference here. But with the 405 nanometer laser, without the pulsing, not much difference. 450, 532, you can see something has changed. 598, 650, and this is cycling. This is Michael Hobson cycled the water, and you can see he made the biggest change of all. The conclusions we had for this is that treatment with some lasers made a small difference in the spectral transmission. Would letting the laser water set sometime, would that have increased the effects? And we don't know because we didn't do it. But there's some hint that the setting time may be important. And treating by conscious intention with cycling did make a large difference. This is Lauren Zanier's water. This is the last one. He calls it the fountain of youth water. This is the Nell laser on it. The 405 nanometer laser, 450, not much of a change, but 532 here, there is a change. 598, again the change. 650, a big change. And this is conscious intention cycled, the biggest change. So here's our conclusion. Treatment with the different magnetic polarizations made measurable differences using the vector network analyzer. The copper orb, a shape. What physics tells me that that shape is going to influence properties of the water? It did make a difference. And conscious intention made measurable differences using both the impedance analyzer and the spectrometer. And please note that on the impedance analyzer, I'm not just measuring magnitude, I'm measuring phase and magnitude. And the results I showed you was actually greater in the phase than in the magnitude. Future work should use experimental protocols that begin to reduce some of the variations we've seen. And it would be nice to be able to use all instruments in each of the experiments and include experiments using quartz crystal treatments, which I didn't get a chance to do in this round, have used them, and I'll just tell you that we have been able to imprint quartz crystal with intention and have the quartz crystal with a magnet, with a geometric shape, transfer that or broadcast that intention and alter pH of water, very much in the same kind of experiments that William Tiller did to use his meditation with an instrument to change the pH of water. Thank you for your attention.